Welcome to the Security Protocols lesson. Click Next to get started. After completing this lesson, you'll be able to achieve these objectives. Define security protocols. Describe different security protocols. A protocol provides a set of rules and methods used to establish a communication between different devices. Consider two people having a private conversation in a different language. While the speakers may think that their conversation is private because they're using an uncommon language, a third person who's listening could use a translator to discover what the other two are saying. To avoid having their conversation leaked, the speakers may decide to speak in a code language that is only known to the two of them, thereby encrypting their data. Similarly, a security protocol protects data delivered through an encrypted communication between two authenticated and legitimate participants. Previously, in a network environment, protocols were initially defined in clear text. For example, emails used multipurpose internet mail extensions, MIME. Web browsing used HTTP, remote control used Telnet, and finally, remote access used L2TP. However, as security became a mandatory requirement, former protocols evolved. In the previous examples, security was added to emails through Secure MIME, S-MIME, to web browsing through HTTPS, to remote control through SSH, and to remote access through IPsec. Click the underlined term for more information. How are protocols secured? For S-MIME, first the email is first signed with the sender digital signature before being encrypted with the receiver public key. After the email is sent, the receiver decrypts the email with their private key, and the digital signature confirms the identity of the sender. Therefore, security is added through the digital signature, which provides authentication, non-repudiation, and data integrity. End-to-end encryption provides confidentiality. In the case of HTTPS, the security is provided by Transport Layer Security, TLS. As the client initiates the connection, the server answers providing their public key. The client generates a random session key and encrypts it with the server public key before sending it to the server. The server decrypts the session key with its private key. The web traffic is then encrypted through this symmetric key, which uses less resources than asymmetric encryption. Because it does not include authentication between the client and the server, this communication is subject to the man-in-the-middle mechanism, MITM, where an intermediate device intercepts the initial HTTPS connection over the default port 443 and creates two sessions. Click the underlined terms for more information. The same authentication is included in the SSH protocol because it performs a verification of the end-to-end connection. The client's public key is already stored in the SSH server. Therefore, when the SSH server receives a connection request from the client, it sends back a random message encrypted with the SSH client's public key. The client receives this encrypted message and decrypts it with its corresponding private key. The client sends back the message to the SSH server. If the message corresponds to the initial message, the client is authenticated. Further communication encryption is implemented through the Diffie-Hellman DH key exchange. This communication also includes integrity with a message authentication code, MAC, algorithm, available in SSH Protocol version 2. SSH Protocol is commonly used for file transfer, like Secure Copy Protocol, SCP tunneling, and network management over default port 22. Click the buttons for more information. You have reached the end of the lesson. You are now able to define security protocols, describe different security protocols,